All right, 7th graders, we are in section 6.7, talking about scatter plots and equations of lines. So we're going to first start talking about how do you write an equation based on a scatter plot. Now, as you've already done, a scatter plot is just a bunch of points that have a trend. You could have a positive trend or a positive correlation, negative trend, negative correlation, no trend, or a trend of 0. So let's start by graphing our first scatter plot. So example number 1, make a scatter plot of the data at the left. Draw a trend line and write its equation. Now the trend line might also be called a line of best fit. Use the equation to predict the wingspan of a hawk that is 28 inches long. So the first thing we're going to do is write this or draw this into a graph. Now I'm going to tell you right now to make note that not everyone is going to have the same answer. These are just like predictions based on the graph. So not everyone is going to have the same line of prediction, the line of best fit. So make note that you might not have the same answer as the person sitting next to you. So we're going to first graph X and Y based on length and wingspan. Now I notice here that my length doesn't start until about 16. My wingspan doesn't start until the 30s. So I'm actually going to draw little break lines both ways. Now my X and my Y, we have to label. So this is length in inches. And wingspan in inches. And the title would be Length and Wingspan of Hawks. And I'm just going to number by, I'm going to start at 14. And I'm going to count actually by, let's say, 2s. 16, 18, 20, 22, 24. And on my y-axis, let's count by, I'm going to start at 28, 30, 32, 34, 36, 38, 40, 42. I'm actually going to go up a little more here. That's a 40. Let me re-erase that, make that a little better. 44, 46. All right, that looks about good. So now I'm just going to draw in all of my points. So 21, 36. 21, 41. And I'm going to continue this. So now I have all of my points graphed, all 8 of them. Now as you can see, it is a positive trend. The correlation here is going uphill. So now here's how you make a prediction. We want to draw a trend line and write its equation. And then we're going to use that equation to predict something. So step 1 is just to make a scatter plot and draw a trend line. Here's how you do that. You want to draw a line that's going to go in the same pattern, for example, uphill or downhill, and then also to make sure you have the same number of points above and below. It actually doesn't even have to go through any of the points specifically, but you could actually draw it. See how this one's a little, it's not steep enough. So let me see if I can move that there. So it looks like kind of like that. I'm going to draw a line that looks like this. And I have a red point here. A red point was there, and a red point was there, and a red point was there. So what you're going to do is just estimate 2 points on the line. So I'm going to pick, I'm just completely making this up here. So let's do, oh, I don't know. This point looks good. This point was 1735, so I'm going to use 1735. And I'm going to use, here's a point, looks like 1430. So I'm just going to use those 2 points. And now I'm going to write these 2 points and then make it into an equation. So the first thing we're going to do is a slope. So I'm going to find the slope. So m equals, I'm going to subtract my y values, 35 minus 30, subtract my x values, 17 minus 14, that gives me a slope of 5/3. So because I have a slope and I have a point, I'm going to use point slope form. So that would be y minus 30 equals my slope, 5/3, times x minus my x coordinate. And right now I could write this as my equation. So I have my equation. Now you could actually distribute the 5/3, add the 30, and write it in slope-intercept form if you would like. But now I'm going to use that to predict the wingspan of a hawk that is 28 inches long. So 28 inches long, the wingspan of a hawk if the length is 28 inches long. Well, the length here is x. So all I'm going to do is take my equation and plug in 28 inches as x. So now I simplify. 5/3 of 28 minus 14. Well, 28 minus 14 is 14. That would be y minus 30 equals 23 1/3. I then add 30. And if I add 30, I get approximately 53 1/3, or you could just actually round that, 53.3 inches. So the wingspan would be approximately 53 1/3 or 53.3 inches. You could even say it's between 53 and 54 inches. So let's do another example. Graph the data below and draw a trend line. Find an equation for the trend line, and then estimate the number of calories in a fast food that has 14 grams of fat. So let's draw this. So I've drawn all my points, and now I'm going to draw a line of best fit. So I'm going to kind of fit the points here. I'm going to draw my line. It even could be up just a little bit. So I'm going to use, let me mark them in green. Let's use this point here. And that one was, I think it was 19,388. And let's pick another point. Let's pick one up here. Let's do 35. Now you're like, wait a minute, 35 wasn't a point we've had. We don't have to use a point we've drawn. So 35, actually it looks like almost 600. So I'm going to use 35, 600. So now I'm going to write a line, write an equation of the line using these 2 points. So step 1, I find my slope. 600 minus 388 gives me a change in y of 212. 35 minus 19 gives me a change of 16. So 212 divided by 16 gives me a slope of 53/4. So I'm going to use this equation. Y minus 600 equals 53/4 times x minus 35. So there's my equation. I now want to use that as a prediction to figure out how many calories if I have 14 grams of fat. So I plug in 14 for x. So 14 minus 35, that gives me negative 21, times 53/4 fourths gives me negative 278 and a fourth. So then I add 600, and that gives me approximately 321.75, or approximately 322 calories. And if we look at our chart here, 14 would be about right here, 321, it looks like it'd be right about where the line is. So there's our answer. Example number 2 is line of best fit, but we're going to use a graphing calculator to find the equation of the line of best fit for the data on the right. What is the correlation coefficient to the 3 decimal places? So the first thing is we have to have a graphing calculator. Now, I'm hoping to have graphing calculators in class for you to use, but let's first talk about correlation coefficients. So we can skip over example 2 and we'll fill it in class. All right, the trend line that shows the relationship between 2 sets of data points most accurately is called the line of best fit. A graphing calculator computes the equation of a line of best fit using something called linear regression. On a graphing calculator, it will say linreg. The graphing calculator also gives you a correlation coefficient, R, which tells you how closely the equation models the data. So the graphing calculator will do the entire thing for you and tell you how close it is. Now, -1 means negative correlation. +1 is would be more like positive correlation. So this would be a line going uphill. This would be a line going downhill. And if it's closer to 0, that means there's no correlation at all. So as I just said, when the data points cluster around a line, there is a strong correlation between the line and the data. So if all the dots are closer to a line, it's going to be either closer to -1 or +1. So the nearer R is to 1 or -1, the more closely the data cluster around the line of best fit. In later chapters, you will learn how to find the nonlinear models, which may better describe the data. Now, I know you don't have a graphing calculator. Most of you do not have a graphing calculator. I would suggest at some point you will need one, but it's just a suggestion. The years are going to be represented by your X, and these are going to be represented by your Y. So what you're going to do on your graphing calculator, we will go over this in class, is you're going to use the edit feature of the stat screen on your graphing calculator, and you're going to edit a table. You're going to enter all of these numbers. So you could enter 0 for 1993 and 1 for 1994, and it represents the number of years after 1993. Or like here, it says let 93 be 1993, and 100 correspond to 2000. So this would be you'd enter 93, 94, 95, and so on. Then you enter all of your Y values. You then are going to use your calc feature in the stat screen and scroll down to something called linreg, L-I-N-R-E-G. It will then give you this, and it actually gives you Y equals AX plus B, and it tells you A, and it tells you B. So you just plug 32.3 and repeating in for A, and negative 2,671 and 2/3 in for B, and you've just written your equation. The R value is the correlation coefficient. So look at how close this is to 1. Because this is so close to 1, this line is going uphill. It's a positive correlation. So if we plugged in A and B, as it says on this chart, you would get the equation that looks like this if we rounded it. It is rounded to the nearest hundredth. The correlation coefficient is 0.996.